So my name is Shane Fontaine. This is called the Future of Ethereum Wallets, contract-based accounts, and I'll show you what I'm gonna be talking about today. But first, I'll give you a little background to who I am. I've been in Ethereum and the crypto space for a while. Co-founded Zero Trust, which is an auditing company. We did a bunch of audits, including Open Zeppelin, Augur, Trust Token. During my time auditing, we found an exploit with a certain token in exchanges called the gas siphon attack. But I'm pretty proud of having found that, and so I always include it on these slides. But that's part of my resume. And then more relevantly, I'm a co-founder of Ethereum. We are a wallet provider and dApp login solution that uses contract-based accounts under the hood, which is something I'm talking about today. So to give you a little background, I'll tell you what we have now in Ethereum and then what the future will look like. Right now, we have all your accounts, your MetaMasks, and most of what you use are called EOAs, externally owned accounts. What that means is you have a private key and a public key pair, and you use that data, and you can sign messages and send transactions with those keys. But in the future, what we'll have and what we do have already is called contract-based accounts. And these you can think of them as programmable keys. You can really program your money to do whatever you want. And you can imagine the world of possibilities that gets unlocked if you have programmable keys to your wallet. So I'll dive into what that means. And there's some things you can do with these contract-based accounts when your wallet is a contract instead of just a key. Like I mentioned, you can program it, but you can do things like batch transactions. You can send meta transactions. You can have better security practices. You can recover your accounts. There's a whole handful of things you can do that I'll mention here, and even things you can do that I won't mention. And before I get going, I'll explain what the cons are. The cost is a con. So you can imagine, especially in the last few months, deploying a contract costs a lot of money. And if you have a contract-based account, as the name implies, your account is a contract, so there is an upfront cost of deploying the contract. However, there are gas and efficiency savings that can be created by using a contract that may save you more money over time. So there's a very good chance that by using a contract-based account, you'll save money or far more money than you would if you were just using an EOA. And that's really the only downside to this thing. So this slide is an overview of the rest of the talk. You don't need to read the little details there, but we're going to be talking about what batch transactions are, what meta transactions are, the Web2 style security you can apply here, and then also recoverability. And if you watched the Gnosis Safe talk a few hours ago, that a lot of that touched on this. Gnosis Safe is also a contract-based account. So a little bit of overlap here. But I'll start with batch transactions. I'm sure a lot of you have seen Etherscan page like this. You could see there's maybe 8 or 10 different tokens being transferred. And what you can do with contract-based accounts is you can take all your individual transactions that you're used to sending on, say, MetaMask, and you can batch them all into one and send them off to the network. And there's some incredible cost savings there. To start, for each transaction you send in a batch, it saves you 21,000 gas. That adds up pretty quickly. So especially in high gas price time. So something like this, where you can batch, in this case, token transfers together, it really ends up saving a lot of money in the long term and is really better for the whole ecosystem. That is describing what I was just saying. You'll see here, this is a page from Uniswap V1, if you guys remember this, but what you see there is an unlock button. I'm sure most of you are familiar, but when you send a token, you need to unlock the token first to be sent to a contract at times, and then you also need to send it. So you have an approval step and a transfer step. With contract-based accounts in the future, hopefully those two steps are never needed again, and all of your approvals and your transactions happen in one single transaction. It's efficient. It's one transaction on chain. And it's cheaper than you would if you had, and it saves time. So there's no downside. This is an example of what some people think they're doing when they have to approve and transfer a lot of, or send a lot of transactions on dApps. So we've all seen dApps where you need to send maybe 6, 7, or 8 transactions just to use it. To some of us, it makes a lot of sense, but for most people, that'll never catch on. You never want to see 8 pop-ups on your MetaMask and have to click 8 of them. So batch transactions allow you to batch even up to those 8 transactions in one and throw them all off to the network. And so the user experience is just unparalleled with these types of transactions. And they're becoming more and more prevalent, and it's great to see. Why is this important? Like I mentioned earlier, the money saving, the gas savings is already extremely beneficial, but also the time. If an average Ethereum block is 12 seconds, if you're sending 8 transactions, you could be waiting up to 80 seconds or 100 seconds approximately. But if you batch them all together, you could wait 12 seconds and you could get them all in one single block. So really, this is saving time and money and increasing the UX. And there's not any really downsides to batch transactions. So we really hope to see them be very prevalent in the future. Following that, we have meta transactions. These are transactions that are sent by someone else besides yourself. So going back to the externally owned account that I mentioned earlier, that most of your wallets are, when you send a transaction with an EOA, you sign the message, you sign the transaction, and you send it to the network. And that is totally valid. However, there's something you can do with contract-based accounts where you do the same signing, you sign the message, however, you hand it to someone else to send to the network. And so you add an additional party that can't edit your transaction because you've already signed it, but they will send it to the network. What that does, that unlocks a lot of cool functionality. But let me explain first how that works. And this diagram is explaining that signing I just messaged or explained, but you'll see here that step 1, you sign a message and send it to a relayer. This relayer is basically a server, but you can think of it very similar to as if you were signing a message and sending it to the on-chain. Instead, you send it to a server. The server then sends the transaction on-chain in the same way you would have with your externally owned account. And then all the exact same transactions happen. I'm sorry, all the exact same steps happen, and your transaction gets broadcasted very similar to as if you had sent it yourself. And I'll go over why this is a great advantage right now. So a few things you can do with this. One is you can start charging transaction fees in different tokens. So with an EOA, you can only pay miners in ETH, and that makes a lot of sense. However, since someone else is broadcasting your message, in this scenario, technically they are paying the miner in ETH, and you could pay them in whatever they want. And that means you can pay them in ERC20 tokens. And so here's an example of an Ethereum dashboard where we put DAI first. We promote the usage of DAI, and to do that, we accept DAI through our relayer. So when you use Ethereum and you send a transaction, if you have it configured in such a way, your transaction fees will be paid in DAI, which is a huge UX improvement for a lot of people. And so you can imagine creating an account, depositing DAI, and then everything you ever do on Ethereum will be with DAI, and you'll never once have to touch ETH. Now, ETH will be moving in the background, but you, the user, will never have to deal with it. And it's an incredible user experience upgrade to be able to pay in tokens and use meta transactions in general. Here's an example, if you can see, of paying in DAI. So you'll see in the top of the red box, I sent 1 DAI to someone, but in the bottom there was 0.054 DAI sent elsewhere. That bottom transaction is actually a transaction to the relayer. So this is an example of a transaction where ETH was paid where DAI was used to pay the relayer. And then something else we can do too is sponsored transactions or promotions. And so we work with dApps and we sometimes offer promotions where we cover the cost of transactions. So like I mentioned earlier, the relayer sends the transaction and you pay the relayer. But if the relayer is trying to promote a service or do something, they can say, keep the fee, we'll cover it, and then you just watch an ad or you use our platform. And so here's an example of a transaction where the user sent 5 DAI, but you didn't pay a single fee to Ethereum, and that's a very, very, very big pool of things you can unlock with this kind of feature. And yeah, I'll let you imagine what you can do with that, because it's very powerful in the hands of a lot of people. Something else we can do too is Web 2.0 style security. A lot of us are used to Web 3, and we're very familiar with keys and this and that, and this doesn't apply much. But if we ever want to bring many people into crypto and into Ethereum and the whole space in general, we need to make it more familiar for them. And we can do that with better Web 2 style security practices. Some examples of this are having an IP address allow list and deny list. We can set daily spending limits, malicious DApp blocking. We can use biometric confirmation, and even a per contract function called whitelist. So I'll get into these a little bit here. I'm sure you guys have heard of the hacks and the exploits and this and that, and all of the different things that have happened over the years in crypto. A lot, if not all of these, but many of these experiences could have been avoided with Web 2.0 style security. One example is this. So if you guys remember EtherDelta back in the day, there was a time where someone got control of their domain name and basically changed their front end and stole a bunch of money. MetaMask has a great feature, and this is something I've been discussing with the Web 2.0 style security, where they see a site that is malicious, and other users have experienced bad things, and they'll throw a banner over it and say, hey, we think this is bad, proceed with caution. That's a great example of Web 2 style security on your like Web 3 experience. You can do biometric security. If, say, you go to send a transaction, you can actually confirm it with your thumbprint or your face or something of that nature, and that's it makes people feel more comfortable because that's what they are used to. There's a really fun one here, per contract function whitelist. And so if you don't need to understand code to see this, but when you're using something like Uniswap, what's actually going on in the background, if you do a Uniswap swap, is you're sending an ETH and you're getting tokens back, but in the background, all you're doing is calling this one function. And what contract-based accounts can allow you to do is scope your transactions to just this function. So if you're a casual user, the only thing you'll ever do on Uniswap is call this function. Now, if Uniswap was hacked or there was something wrong with the front end or there's something weird going on, technically someone could take your signature or your transaction and make you think you are trying to call this function, but instead you're calling another function that drains all your money. So there's a few cases where you can be tricked, so to speak, into doing something like this. Now, with a contract-based account with Ethereum or some other player, we can actually scope your account to this specific function. So you can avoid the case where someone basically fakes you into signing a transaction. So in this case, if you were going to transact with Uniswap and something bad would happen, our system would flag it and say, hey, you are not transacting with the function you said you were going to. What's wrong? And we'll stop it and hopefully save you a ton of money. And this is a very, very critical feature that you can expand on the whole ecosystem on different contracts and functions and even parameter inputs. And so it's a very, very powerful thing that doesn't exist with EOAs today, but you can implement rather easily with contract-based accounts in a whole relayer system. And then there's also recoverability. So a lot of Web3 doesn't have a forgot your password button. If you lose your keys, you're pretty much out of luck. And we've seen countless examples of that. Now, with the advent of contract-based accounts, that you have many more options. In that you can almost think of your contract-based account as a wallet, and you do have many keys in the same way you have many keys for your front door, if you have many keys for your front door. So what that means is you can actually set many keys. If you have a Ledger or a MetaMask wallet account or some other key, you can set them all to be owners of your contract-based account, and you can keep all your money in your contract-based account, but you can only access it through certain keys. Obviously, that's very powerful. You can do the same thing with multi-sig wallets, and it's a very powerful thing to be able to have this ability to add multiple keys to your account. And this is, like I was saying, you could have a MetaMask, a Ledger, and a seed phrase account that basically all have certain accesses to your funds without any of them having any actual funds in them, which is extremely powerful. You can also do things like social recovery. I'm sure you guys have heard the term social recovery, but the idea is you can basically trust 3 of your friends or your family members, and if you ever lose your key, if you have previously assigned them and they've agreed to it, you can basically use them collectively to recover your account. And so the implementation is different between everyone who's done it, but the idea is your 3 friends or your 5 friends can't do, any one of them cannot get access to your account individually, but if they all come together through you, then put their keys together, then you can get it back. And what this does is it allows for a forgot your password button. So while that's so simple in Web 2, Web 3, it's not. So on Ethereum, for example, right now, there's a forgot your password button, and you can simply forget your password and recover it with a few restrictions, obviously. But it works great, and it's probably the best UX experience for a user coming into the space. Now, what does the future look like? And this is where it gets a little interesting. So everything I've described is a lot of people are doing it today. Ethereum's doing it. I think Gnosis Safe is doing a lot. There's a ton of people pushing this forward, and it's working great. But the future really comes down to the fact that these wallets are programmable, and you can do whatever you really think of. And because of that, it's the potential is unlimited. And so I'll list a few things here. You can think more about privacy. You can really adjust these wallets to be more private or less private depending on what you want. There's a lot of discussions about account abstraction going on, which would add certain parts of this type of wallet to the core protocol, specifically the meta transactions. And so there's a lot of talk around really taking a lot of the work we've done and a lot of the work a lot of people in the system have done and building it into the protocol, which would be a huge win for everyone. Cheaper interactions, like I said, you save a lot of money using these things. They work pretty well across different layer 2 chains. This has obviously been a very hot topic lately, and a lot of the layer 2 implementations are pretty different. And if they are EVM compatible, there's really no reason why these don't work on other chains. And so what we've seen is that is the case, and works pretty well. And then more granular controls. I mentioned a few firewalls you can add, but you can really add anything from I only want to send money to this one person, I only want to interact with this one dApp. Anything you can think of, you can really tighten your system down to, and you can only use those functions of the system you tied it down to. And so there's a lot of cases where that would be good, and then a lot of cases where you don't need to do that. You can just transact freely like you're used to. But in reality, all these contract-based accounts do is unlock a ton of features for you to choose what you want and pick and choose and implement exactly what you want. And it's incredible UX from a user perspective. And then finally, how do you use one today? Ethereum.com has one. That's the company we started. There's a handful of other companies out there, and all these contract-based accounts are great for the ecosystem. If they are used in mass, and we do start seeing batch transactions and all these gas savings, it's in the long term going to be a much better experience for everyone on Ethereum. So highly recommend checking it out. And that's it. You can check out our website, or really just look up contract-based accounts and see how they work, because the more people who get their eyes on it and their minds on it, they come up with more things every day that even I don't think about. And it's really cool to see people who come up with different scenarios that they can use with these things. So that's the end of my presentation. If anyone has any questions, I'll stay on and answer them in the chat. But thank you for coming.